The equation of motion of a particle is s, which is equal to t cubed minus 12t, where s is in meters and t is in seconds, and assuming that t is greater than or equal to 0. In part A, we want to find the velocity and acceleration as functions of t. So we've written down what this function looks like, which is s, which is equal to t cubed minus 12t. So if we want to find the velocity function is equal to the derivative, or the first derivative, of s. Okay, and so what that's going to equal is the following. We want to find the derivative with respect to t of t cubed minus 12 times the derivative with respect to t of the variable t. So recall that since this is the power rule, we know that this is going to be 3 times t to the 3 minus 1, which is 2, minus 12 times the derivative of t, which is 1. So therefore, we would say that the velocity function is equal to 3t squared minus 12. Okay, now, since we know that the velocity function now is defined as 3t squared minus 12, now what we want to do is we want to find the acceleration function. Okay, so the acceleration function with respect to t is equal to the derivative of the velocity function, which is 3t squared minus 12. So we're going to take 3 times the derivative with respect to t of t squared minus the derivative with respect to t of the constant 12. So we have 3, and that's going to be times, okay, the derivative with respect to t of t squared is going to be 2 times t to the 2 minus 1, minus the derivative of a constant is 0. So therefore, 3 times 2 times t is 6t. So therefore, the acceleration function is 6t. Okay, so let's take a look at part B. So part B wants us to find the acceleration after 6 seconds. So that means that in our problem, we know that t is going to equal 6 seconds, and then we're going to plug it into the acceleration function, a of t, which is equal to 6t. We want to find a of when t is equal to 6. And so we would say 6 times 6 is then going to give us 36 meters per second squared. Okay, the next question says the following. It says, find the acceleration when the velocity is 0. So we want to use the velocity function. So that means that tells us that v of t is going to equal 0. So that means if we had the function 3t squared minus 12, and that's equal to v of t, we're going to set that equal to 0 because we want to make the velocity equal 0. So 3t squared minus 12 is going to equal 0. Now what we're going to do is we're going to solve for t. So if we add 12 to both sides, we get 3t squared, which is equal to 12. And then if we divide both sides by 3, we get t squared, which is equal to 4. Now, if we take the square root of both sides, we get t, which is equal to plus or minus the square root of 4. So we have t, which is equal to negative 2 and positive 2. Now, keep in mind, up here, it tells us that we have to assume that time has to be greater than or equal to 0. So that means we have to eliminate the negative version of this. Okay? And so now, in the second part, because if this is the first part, the second part is to find the acceleration when the velocity is 0. When the velocity is 0, we found that t is equal to 2, and then we're going to plug it into the acceleration function of a of t, which is equal to 6t. So we want to find a at when t is equal to 2. So 6 times 2 is going to give us 12, and that is 12 meters per second squared.